Okay, this is a lesson about the area of composite figures. We will be looking at composite figures. We will be identifying the shapes that they make up. We'll be adding them together and getting a total area. And if we read what's in the box, it describes what we're going to do in other words. To determine the area of a composite figure, decompose the figure into shapes, whose areas you know how to determine, then determine the sum of these areas. So let's look at the first composite figure, our example. It looks like we have a semicircle, we'll call that our figure 1, and we have a trapezoid, and that will be our figure 2. So the area of a circle would be pi r squared, but we have half a circle, so we'll make sure we write it as half pi r squared. They give us diameter, not radius, so we'll need to take the diameter divided by 2 to get a radius of 7. Then we can substitute in 3.14 for pi, and 7 for r, and square it. Area then equals 7 times 7 is 49 times 3.14 divided by 2, and that will give you 76.9. Okay. Then we will look at our trapezoid, number 2. And the formula for a trapezoid is area equals B1 plus B2 over 2 all times H. So let's identify our variables. B1 will be 14 inches. B2 will be 18 inches, and our height has to be 10 inches. Now we'll plug in our numbers. 14 plus 18 gives us the B's, and then our H is 10. Solving, 14 plus 18 is 32 over 2 times 10. 2 divided into 10 gives us 5. 2 divided by 2 is 1. 32 times 5 gives us 160. Now we've found area of the semicircle and the trapezoid. So now we'll find the total. Equals 76.9 plus 160, and that will equal 236.9 inches squared. And that's your total. Okay. And once again, to determine the area of the composite figure, we found the area of the semicircle and we found the area of the trapezoid, and we added them together. Okay, next page, or rather the bottom of your page. Exercises. Let's look at these below. Determine the area of each figure and round to the nearest tenth if necessary. Okay. All right. So if we look at our first composite figure, we have 1, a parallelogram, and 2, a semicircle. So the area of a parallelogram equals base times height. The base which is just like the top, 8 millimeters, is B, and H is 5 millimeters. So the area equals 8 times 5. Area is 40. Now if we look at number 2, which is our half circle, remember that the area of a circle is pi r squared, and we'll take half of that to get our semicircle. They give us a diameter of 6, so we need to take our diameter and divide it by 2 to get r, so that would be 6 divided by 2. Okay? So the area equals 1/2 3.14 times 6 divided by 2 gives you 3, and don't forget we have to square it. So then if we multiply all the numbers together, 3 squared is 9 times 3.14 divided by 2 will give you 14.1. Now we've found the area of the parallelogram and the area of the semicircle, so now we'll add them together. Area equals, let's write total. Total area equals 40 plus 14.1, which equals 54.1 millimeters squared. There. Okay. Now we just have one more to do. What we have here is a triangle, so we'll call the triangle number 1. And we have a parallelogram. Let's call that number 2. So for number 1, we have area of a triangle equals 1/2 the base times the height. Well, the base of this triangle is 12, and the height equals 10.4. So we'll put that in to our equation. 12 times 10.4. Okay. We'll go ahead and get rid of that 12 and make it a 6 by dividing by 2. Also divide 2 by 2 to get 1. So the area of our triangle will be 10.4 times 6, which is 62.4. Okay, so now let's get the area of our parallelogram. The area of a parallelogram is area equals base times height. We've already found the B to be 12, so we'll just use that again. The height of our parallelogram is 10.8. So the area equals base of 12 and a height of 10.8. Okay, if we multiply those together, the area is 129.6. So if we take our triangle and our parallelogram and add them together, the total would be 62.4 plus 129.6, which equals 192 meters squared. Okay, so once again, we looked at our figures. We decomposed them into two parts. We found the area of the shapes, and then we added them together. That concludes our video on composite figures.